Okay, pause and copy. Pause and copy. Okie doke. So the idea here is to not do humongous calculations. Use some row operations. Maybe I'll emphasize create zeros. I want to create zeros because zeros make the determinant easier. Okay, I'll give an example for C down here. Let's see. Okay, here we go. Here's an example for part C. You should pause and copy that to show you how part C works. It works as a kind of factoring. You can think of it that way. This row has a common multiple of 2, so that can move out front. If you were to have another, let's say you had 3, 6, 4, 8, you could bring the 3 from the first row out and the 4 from the bottom row out, and you get 1, 2, 1, 2. Okay, so that's how part C works. Okay, let's do a 3 by 3 to illustrate how this works in practice. Okay. Oops. 1, 1, -4, 2, -2, 8, -9, -1, 7, 0. Okay, so my preference is to restrict myself to replacements. So I'll say only use replacements because replacements, as we saw in part A of theorem 3, they do not change the determinant at all. So if I do some replacements, if I do row 2 plus 2 row 1 and row 3 plus row 1, okay, those are replacements. Replacements in general are like Ri plus a multiple of some other row. The point is you cannot have some multiple here that's not equal to 1. So this is a replacement in general. So, and k can be negative, but anywho, what do we get? 1 minus 4, 2, 0, 0. Adding twice gives me -5 here. And then adding gives me 0, 3, and 2. Okay, at this stage, I would say, well, look, my first column is looking pretty good. So I use theorem 3 here. Okay, it tells me that these two determinants are equal. Okay, so I do a cofactor expansion down the first column, and I have just one term because in this column, there's only one entry that is non-zero. So what do I get? So I get 1, 0 plus 15, giving me 15. Very quick, right? Okay, let's do another example. 4 by 4. Make sure I copy this down right. It would be a disaster if I didn't. 1 minus 4, 0, 6. Anytime you copy down a matrix, it's always worth double checking. I do it automatically because I have made a lot of mistakes in the past, and I have learned to measure twice, cut once, as we say. Okay, I want to create zeros in a way that is convenient. Convenient. Okay, so what is convenient? I got this 1 here. I should use that 1 to kill these entries here. That's my first impression. So I'm going to leave the bottom row alone. Okay, so what am I going to do? I'm going to do row 3 plus 3 row 4. I'm going to do row 2 minus 3 row 4. And I'm going to do row 1 minus 2 row 4. These are all replacements, so they do not change the determinant. Okay, notice I'm using an equal sign here. That is appropriate because this is a number and it equals this number here. Okay, determinants are numbers. They're no longer matrices. Okay. 0, add 3. Minus 12, add 3, 1, 16. And then 0, subtract 3 times 5, minus 8, and then subtract twice, 0, 0, 6, minus 4. Okay, check that against my solution. Okay, good. Okay, now I've created zeros. Why don't I do a cofactor expansion down this column? So I'm going to get a 1. Is that going to be a plus or a minus with that one? Well, it's going to be a minus, right? So put a minus there. Then I get a 1 times the remaining 3 by 3 determinant. Okay. Now I say, what's the easiest thing to do here? The easiest thing is to use this 3 to kill the 12, minus 12. So what's the operation? Row 3 plus 4 row 2. So I get, what do I get? 0. 16. Minus 16. No, I made a mistake somewhere. What did I do? This is not right. 21. A little boo-boo here. 21. Okay. Then I'll do a cofactor expansion down this nice column. Let's use some brackets here. That is a minus 3 times the 2 by 2 determinant, like so. So let's see, I get just 3 here times the determinant, which is minus 96 plus 84, which is 3 times negative 12, negative 36. That is correct. Okay, let us review. Yeah, I used the first column here and I used it again here. That's coincidence, it's going to depend on what's convenient. I said, looking at this column, I said it's convenient to use this one to kill these guys. It may have been even more convenient. In fact, I recommend you try this another way. Why don't you try to do this a different way? Maybe you'd say, oh, look, I can use this one to kill these two. That'll save me an operation. Why don't you try that? Okay, if you're looking for some more practice, restart. And your first steps should be to use this to kill these two. Okay, so what you may find is that if you go down a certain path, the numbers start to explode. Okay, these numbers, see this 21, this minus 16, that is these numbers can get out of hand if you kind of go down the wrong path. So if you're doing operations like this and you find your numbers getting into the hundreds, I would start over and take a different route. Okay, that's worth repeating. If you find your numbers exploding, these aren't too bad. Double digits are okay, but if you get triple digits, maybe come back and try a different path towards your determinant.